Hey guys, welcome back. We're going to do number 2. This is Unit 4, handout 5B. It's going to be the second question, number 2. It's on page 1. And have a look. It looks exactly like the other one, except for it's got all different values. One rung with a capacitor, one rung with an inductor, one rung with just a resistor. Look at this one. It only wants the impedance, the phase angle, and leading or lagging. It doesn't ask for any currents. That's because I have not provided you with a voltage. And so depending on what voltage you use, you will get different values of current, but shouldn't change your impedance, your phase angle, or whether the circuit's leading or lagging. I'm going to do this one using 100 volts. You can use any voltage you like. Be aware that if you use a different voltage, you will get different currents, but it won't matter. It'll still work out. So if you want to try it and make it the same as mine, use 100 volts. Okay, guys? So we're going to do it exactly the same way. 4 bits of information. Remember that the rung with the inductor is going to be lagging, and therefore its angle is going to be negative. So I'm going to put that negative sign there right now so I do not forget. The impedance is going to be 9 squared plus 4 squared square root. So I'm going to do this kind of quietly and kind of quickly, okay? I is going to be E over Z. We decided to use 100. 10.15 amps. Phase angle, opposite over adjacent, inverse tan. 9 divided by 4 equals shift tan equals 66.04 degrees. We're going to leave that angle alone because I know that current is going to be leading. Same with rung 2 here. It's going to be 22 squared plus 20 squared equals root equals. This is going to be 29.73 ohms. I is going to be 100 divided by that answer. 3.363 amps. Angle is going to be opposite over adjacent, inverse tan. 22 divided by 20 equals shift tan equals 47.73 degrees minus, okay, because it's lagging. Here, I looks like it's going to be 10 amps. Phase angle is going to be 0 degrees. All right, so I am going to calculate the horizontal component now. And if it's okay with you, I'm not going to write the whole thing out, okay, because it's going to be 10.15 cos that plus 3.363 cos that plus 10 cos that, and that's it. So I'm just going to punch it all into my calculator. Making sure I make that negative. Okay. I'm using sine now. Whoops. Okay, so for my vertical component, I'm getting 6. Now, by the way, I'm going to draw these phasors over here because we should be drawing the phasors, and I kind of skipped it. So I just want you guys to see what these current phasors are going to look like. We're going to get 10 at 66, so 10.15. 3 at minus 47, 3.363. Last one is going to be 10 at 0. Okay. Total circuit current, I total, vertical component, horizontal component. Okay, so you can see what it looks like there. You're going to need that to figure out whether it's leading or lagging, basically, right? Or at least it's going to help. I'm going to calculate I total right over here. Should be 6.787 squared plus 16.38 squared equals root equals 17.73 amps. Okay, now we haven't solved anything yet, okay, but now I can calculate Z. It's going to be E over I. E total over I total, and we just calculated I total, and the E total is 100, so it's going to be 100 divided by answer, 5.64 ohms, okay? 5.64 ohms. Phase angle, guys. So finally, we got A here. I'm going to do B over here. B, phase angle is going to be opposite over adjacent, inverse tan, okay? 6.787 over 16.38. 6.787 divided by 16.38 equals shift 10 equals 22.51 degrees. Okay, leading or lagging? Have a look, guys. NASCAR leading. All right, guys. So, you know, we got her figured out. Hey, now, guys, I said it before. These guys are, well, you know, lots of things to go wrong. Many calculations. Every calculation needs to be done perfectly in order to get the correct answer. If you make a mistake anywhere, it's going to make everything wrong. Okay, so you have to go slow. Carefully calculate everything. Make sure you're putting a negative sign in the rung that has the inductor. Carefully calculate your horizontal and vertical components. All right, guys, carefully calculate everything, basically. All right. Now, by the way, guys, I hope you guys are well at home. I hope that you're keeping up with the homework. If you have any questions, make sure you ask. You know, send me an email, something like that, and I will answer you. I've been getting some emails from some students, and I'm trying to, you know, get answers for everybody who has questions. And so don't worry about, you know, bugging me or whatever. That's what I'm here for. Also, I miss you guys. You know, this is going, I hope, okay for you. I know it's not the same as in class. I miss your smiles and I miss your, you know, interaction. And so take care of yourselves, guys, and we're going to keep going. So let me know. Have a good one.